this video we're going to introduce the idea of an elementary row operation and see how to perform these kinds of operations on our matrices. Now often what's going to happen is we're going to be given a matrix and we would like to get that matrix into either REF or RREF. And there are three different types of operations we're allowed to do, and those operations are called elementary row operations. The first kind of operation we can do is we could take all of the entries in one row and multiply them by a non-zero number. The second kind of operation we can do is we can take a multiple of one row and add it to a different row. And finally, the last kind of operation we're allowed to do on our matrix is to interchange any two rows of that matrix. Let's take a look at what a type 1 elementary row operation might look like. Now I want you to take a look at this matrix that I have on the left here, and notice that it's really close to reduced row echelon form, but this 1/2 is preventing it from being in reduced row echelon form. So remember that in row number 2, the first non-zero number that we hit has to be a 1. So what we could do is we could take row number 2 and we could multiply that fraction by 2, and that would create a leading one for us. Now to write a type 1 elementary row operation, what we have to do is we have to indicate which row we would like to do the multiplication in. So here I'd like to do the multiplication in row number 2, and what I'm going to do is I'm going to multiply row 2 by the value of 2. So 2 goes out front, you can put a star if you want, you can put a dot, whatever helps you remember that we're doing a multiplication of row 2 by the number 2. And how we have to think about this one is we're actually going to take all of these entries, 0, 1/2, and 0, and we're going to multiply all of them by 2. So what we would get is we would get 2 times 0, which is 0, 2 times 1/2, which is 1, and 2 times 0, which is 0. And these values become our new row 2. Okay, so we take these values 0, 1, 0, and they get inserted into row number 2. And here's our new matrix on the right. Now where type 1 elementary row operations are really beneficial is for us to remove fractions from our matrix. So what I want you to do is take a look at row 2 of this matrix and see if you can figure out a number that we could multiply by to remove all of these fractions. Yeah, so if we take row number 2 and multiply by 8, that should get rid of all of these fractions for us. So let's take all the values from row 2 and rewrite them down here. So 1 over 8, negative 3 over 2, and 7 over 8. We're going to multiply all of these by 8. So 8 times 1/8, that's 1. 8 times negative 3 over 2, well, that's the same as negative 3 times 4. That would give us negative 12. And 8 times 7 over 8, that would give us 7. So these values here would be our new row 2 for our matrix above. Alright, so there it is. We would take these new numbers we get and insert them into row number 2. Next, let's take a look at type 2 elementary row operations. These are operations where we add or subtract a multiple of a different row. Now, if we look at the matrix that we have now, again, it's really close to reduced row echelon form. The only thing that's preventing us from being in reduced row echelon form is this number 2. Now here's where we have to be careful. We can't do an operation that looks like this. We can't simply go row 2 minus 2. That's no good. That's not an elementary row operation. Instead, what we have to do is we have to take row 2 and subtract a multiple of another row. Okay, in this case, what we're going to do is we're going to take 2 times row 1. Okay, so let me show you what this looks like. What I'm going to do is I'm going to write down row 2 is 2, 1, 0, and we're going to subtract 2 row 1s, and row 1 is 1, 0, 0. Okay, if we were to simplify this a little bit, we'd have 2, 1, 0, minus 2, right? We get 2 times 1, 0, 2 times 0, and 0, which is 2 times 0. Okay, and if we were to look at each of these individually, so here we have 2 minus 2, that would give us 0. Next, we have 1 minus 0, that would give us 1. And finally, we have 0 minus 0, and that gives us 0. So here it is. Here's our new row 2 for our matrix above. Okay, so our final steps would be to take these 3 values and insert them into row number 2. Now we write this operation in a very particular way. Since we're using 2 different rows, row 2 and row 1, we need to understand which row is the row that's changing. We'd like to change this value of row 2, so I usually write down row 2 first to indicate that row 2 changes. That's where we're inserting this new information. Right? So after we've done our computation here, we get these new numbers which go into row 2. Even though we've used row 1 here, row 1 does not change. Okay, take a second to pause the video now and see if you can write down the operation that would change this minus 5 into a 0. Did you come up with row 3 plus 5 row 1? So we're going to look at row 3. Row 3 is minus 5, 0, 1. And we'd like to add 5 of row 1's. Row 1 is 1, 0, 0. Okay, so we still have minus 5, 0, 1. And if we multiply all of these numbers by 5, we'll have 5, 0, 0. And we're going to add these piece by piece. So minus 5 plus 5 will give us 0. 0 plus 0 will give us 0. And finally, 1 plus 0 will give us 1. So this is our new row 3. Alright, so notice I've placed these values that we got at the bottom into row number 3. Why did we place it into row number 3 and not row number 1? Well, row 3 was the row that's changing. We're trying to change this minus 5 into a 0. Finally, type 3 elementary row operations are probably my favorite because they're generally the easiest ones to think about and to perform. We don't often use row switching, but it does come in handy when things are out of sync. So for example here, if we look at row 1 and row 2 of this matrix, it'd be nice if we could switch row 2 into row 1 and vice versa. And in order for us to write this operation, we're going to say I would like to switch row 1 and row 2. And we indicate that 2 rows are switching with a double-sided arrow like this. Alright, so here's what our final matrix would look like if we perform the switch of row 1 and row 2. Notice that row 1, 0, 1, 0, has been moved now down into row number 2. And we have that row 2, which was 1, 0, 0, is now moved up to row number 1. Often what we want to be able to do is perform several of these operations in a row in order for us to get to reduced row echelon form or to row echelon form. And I'm going to demonstrate a string of 3 operations here on this given matrix to get it to reduced row echelon form. Now what I'm going to do first is I'm going to take a look at row number 1. Okay, so I'm focusing on this row, and I notice that the first number I hit is not a number 1. So I'm going to change this into a 1 by multiplying row 1 by negative 1/3. Now I want you to notice here, multiplying by negative 1/3 is the same thing as dividing by negative 3. So all I'm doing is I'm taking all of these numbers and dividing by negative 3 to obtain a new row 1. Okay, the next thing I notice is that these leading ones here are not in the right order, so I'm going to switch row 1 and row 2 to get them back into the step pattern. Alright, so what I'm doing is I'm taking this row number 1, 0, 1, 0, and I'm making that my new row 2. And I'm taking row 2, which is 1, 0, 4, making that my new row 1. The last step we have to do is we have to change this 4 into a 0. So right now we have row echelon form, but I'd like to get this to reduced row echelon form. And the way to do this is we could change row 1, so I could take row 1 and subtract off 4 row 3s. You should try that operation on your own. What I'll do is I'll put a little bubble over on the side that shows this operation, and we should get a final matrix that looks like this, and this is our reduced row echelon form. So to end the lesson, I just want to go through a couple of notes to help you tie some things together. The first note is that type 1 operations, remember these are operations where we multiply by a non-zero number. These kinds of operations are very useful for removing fractions, and they're very useful for us to create what are called leading ones. Okay, this is going to be really important for us in some upcoming lessons. The second note regards type 2 operations. Now these operations are really useful for creating zeros. Okay, in future lessons we're going to be creating zeros above and below leading ones, and we're going to be using type 2 operations in order to do this. The last note is you may have noticed me use this symbol here, this little squiggly line, this tilde, and usually we use this symbol after we've performed an operation on a matrix. When we do an operation to the rows of a matrix, we actually change that matrix. We cannot write an equal sign. So we use this sign just to denote that the new matrix is a little bit different from our previous ones, but all of the properties of the previous ones move to this new matrix that we've created. Alright, my little epsilons, stay positive.